Okay, so in this video we are going to continue with the question that we decided to solve. Okay, all right, so let's continue with the a subscript n. We are continuing with a subscript n. We've already found a naught, so let's find a subscript n, and the formula for a subscript n is 1 over p integral of from negative p to p f of x cos n pi x divided by p dx. So this is the formula for a subscript n. So now we already know that our p is equal to pi. Okay, so let's put the pi there. Now let's plug the pi in. So it's equal to 1 over pi integral of negative pi to pi, then our f of x, we have our cos n pi x over pi dx. Yes. So here we can see that this pi can actually cancel out this, so it's going to be left with a subscript n is equal to 1 over pi integral of pi minus pi f of x, then cos nx divided by, so it's only nx. Okay, it's only nx dx. So that's it. So now that we have it like this, we already know that, or in the question the interval was pi to pi. Okay, pi to pi, I mean negative pi to pi. But then within the negative pi to pi there was two functions or two intervals where when it occurs we are going to get a function. So for the two intervals it was negative pi to 0, and that occurs when the function is 0, and then we have pi to 0, and that occurs at pi and negative x. Okay, so we can see these particular two intervals in these two functions are within this interval. So since they are within this interval, we are going to take the function or the interval with respect to the function and add it to this. So it now becomes 1 pi, then bracket opened. We are considering the first one. Okay, so integral of negative pi to 0. So at negative pi to 0 the function is 0, then dx, then plus another integral, and here it is 0 to pi, so 0 to pi, and at this interval, within this interval, the function is pi minus x. Okay, something like this. Then don't forget your dx. Okay, so I think I've made some mistake here. You know, the cos, we didn't bring the cos. I really omitted the cos, so let's bring it back. Okay, so bringing back the cos, going to be cos nx dx, then plus integral of 0 to pi, and at this interval the function is pi minus x. Okay, then we bring, so this, the whole thing, the whole of this is in brackets, then we have our cos nx dx. Okay, so this is it. So now what we are going to do is that we are going to solve each term. We are going to solve for each term. Okay, so in solving for each term, that means the basic knowledge that we have on integration, that's what you are going to apply here, right? So when you get to this part, it's really not a big deal. you just use your general knowledge that you know about integration, then you do it. So at this point, this is 0. Alright, this is 0. So if we integrate 0, obviously the whole of this becomes 0, because if we integrate 0, the answer is 0. So 0 times cos blah 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 is 0. Okay, so here 0, we are not going to write anything, so we are going to focus on this. Alright, so focusing on this, so it becomes integral of pi minus x, then we have our cos nx dx. Okay, so now we are going to solve this, simplify this. Okay, so let's clean up this place so that we can continue. Okay, so now solving for this, we can see that this particular function here is of two functions. So here it's one function, this one is also for one function. So since there are two functions multiplying each other, here we can use integration by parts. Yes, we are going to use integration by parts to compute this. Okay, so in order to use integration by parts, we know the formula for integrating by parts, and the formula is integral of u dv, okay, is equal to uv minus integral of v du. So now we are going to compare the formula with the question here. Our main focus is on this. Remember, it's not on the 1 over pi is not really included, so our main focus is on this. So using integral by parts, we are going to compare the question with this. Okay, so we are going to take one of this function, we are going to take that as our u, and one of them as our dv. So which one is going to be our u, which one is going to be our dv? So let's take the pi minus x to be our u. Okay, so let u be equal to pi minus x. Okay, pi minus x. So integrating this or differentiating this is going to be du dx. Okay, so here you see it is du dx, meaning we are going to differentiate this with respect to x. So our main focus is on x. Therefore, the pi is going to be treated as a constant. All right, and we know that if you differentiate a constant, it is 0. If you differentiate a constant, it is 0. And also differentiating x is 1, but there is a negative attached to it, so it is minus 1. And if you look at the formula, there is du here, so we need to find du. So finding du, let's make the du the subject. Okay, so making du the subject, we are going to multiply through by dx. So multiply this one by x, by dx, the x cancels, then we multiply it by the negative one, so it's going to be negative dx. Okay, all right, now dv now becomes cos nx dx, which is cos nx dx. So these are dv. Now let's integrate this. Okay, so we want v, so in order to get v, we need to integrate this. So integrating this, you can see that this is actually it's not like cos x, that if you integrate cos x, you're going to get sin x. Okay, this one, it is two functions. There are two, it's a function here, or it's not only x, there is n attached to it, so you can't compute it this way. So in order to do that, we need to differentiate what is inside the bracket here, or what is inside the sign. Actually, there should be a bracket, so we need to differentiate. So differentiating this, it becomes n. So finding du dx, so y is equal to, let's make y to be nx. So du dx of this is going to be n. Okay, and we know that differentiating cos, differentiating cos, you're going to get sin. So the final answer for differentiating cos nx is sin nx all divided by n. That is going to be for v. So we have our v now. Okay, so now we have them all. So what we are going to do next is that we are going to put the individual quantities we got into the formula. Okay, so here, don't forget our 1 over pi. Don't forget our 1 over pi. So we are going to put them into this. So IU is equal to pi minus x. So we have half pi minus x. Then our v is sine nx all divided by n minus integral of, now our v is sine nx divided by n. Okay, then our du becomes minus dx. Okay, so this is what we are getting. Then we don't forget our interval or the limit, which is pi is to that is 0. Okay, so now what we are going to do next is that we are going to simplify this, because integral of sine nx over n is actually not the simplification of it, because since we have the integral sign, it means that this is not really complete, so we need to complete it. So in order to complete it, should we do it somewhere and bring it inside? Okay, let's do it. Let's solve that here and bring it inside. Okay, so integral of sine nx divided by n. So this is actually minus dx. Okay, minus dx. So let's fix the minus dx outside. The minus, let's send it outside. So bring in the minus here. It's going to be dx. Okay, so now let's actually bring the n, the denominator n, so let's bring that one outside. So it's going to be minus 1 over n. So that means here we need to clean this. Shit. Okay, so having it like this, now it becomes easy for us to, integrate it. It becomes very easy for us to integrate. So integrating this becomes minus 1 over n. Then integrating the sign is negative cos. Okay, so it is negative cos nx. Then we differentiate what is inside here and divide it by the result we get, and that is n. Okay, so here multiplying this by this, it's going to be positive, and the n here too is what? Multiplying this becomes n squared, so it's going to be cos nx divided by n squared, and we're going to plug that here. Okay, so we're going to put that here. We're going to put that here. Okay, so we have our 1 over pi, bracket open, we have pi minus x, then the sine nx over n. Okay, bracket close. So we have our minus. Actually, this particular minus we didn't, so it comes, so minus. So we are coming in place of this, we're going to put this. Okay, so it's going to be cos nx divided by n squared. Okay, so that's what we're going to do. Then bring our pi and 0. So now that we have it like this, we are just going to we are going to plug in the pi. Okay, we are going to plug in the pi minus plugging in the 0. Okay, just like we did for the previous ones. or just like we knew in calculus with respect to integration. Okay, so let's do that. Okay, so just like we know, we are going to plug in the pi. So 1 over pi, bracket open, pi. So it means that wherever we see x, we are going to put pi there. So here it becomes pi to bracket, then sine n pi. Okay, sine n pi, all divided by n, then minus cos n pi, all divided by n squared. So this is 1 term, minus pi minus 0, bracket open, sine n times 0, all divided by n, minus cos n times 0, all divided by n squared. Okay, so all into bracket. Okay, so this is what you are getting. So now let's simplify it further. Okay, so let's write our 1 over pi first. Now considering this, pi minus pi is 0. Okay, pi minus pi is 0. So if there is 0 here and this 0 is also multiplying this, it means the whole of this particular part is what is 0. So it's going to be left with only this. So it's going to be left with cos n pi, all divided by n squared. Then we have our minus. Now looking at this one too, pi minus 0, that one is pi. Okay, multiplying sine n times 0. So n times 0 is actually 0. So it's going to be sine 0, and sine 0 is what? Is 0 divided by n. So 0 divided by n is 0. So it means the whole of this part is 0. So now let's consider this one. Because considering this one, the 0 here multiply the n, meaning it's going to be cos 0. And we know that cos 0 is what? Is 1. Yeah, you can punch on your calculator and confirm. So cos 0 is equal to 1. So it's going to be left with this. So this is what we are going to bring from here. So it's going to be actually minus 1, because cos 0 is 1, all divided by n squared. Okay, so this is what we get. Now we have 1 over pi. So let's erase this, and that's going to be minus cos n pi divided by n squared plus 1 over n squared. So this is what we get. Okay, so now you can see that the n squared, 1 over n squared, is really common here. It is common here. So since it's common there, let's factor that out. Right, so factoring out, it will multiply with this, and that is going to be 1 over, that's going to be 1 over pi n squared, then brackets open, then we bring the whole of this. So if we factor the 1 over n squared out from this, then that means there is not going to be any n squared here again. It's going to be left with cos n pi, then plus 1. Alright, now this is what we are going to get, plus 1, and that's it. Okay, so at this point there's something that you need to take note. Okay, it's like a rule, it's constant. Okay, so whenever you have cos n pi, the answer is actually -1 power n. Then if you have sine n pi, that is equal to 0. Sine n pi is equal to 0, and cos n pi is equal to -1 to the power n. Okay, so let's use that particular rule here. So it's going to be 1 pi n squared bracket open minus. So here, since we know already our cos n pi is minus 1 to the power n, so it's going to be minus 1 to the power n, then plus our, and that is going to be 1 over pi n squared bracket open. So this affects that, so it's going to be 1 power n plus 1. So this is what we are getting for a subscript n. So a subscript n is equal to 1 over pi n squared bracket open 1 power n plus 1.